Let's say you finally got a chance to drive a McLaren F1 race car. You sit in the car, and the first thing you ask is, "Where's my helmet?" They say, "No, you don't get a helmet. What about a seatbelt?" "No, no seatbelts." And you look in front of you, and all you see is a country dirt road. Are you going to feel very comfortable, even though you have one of the fastest machines out there, to take a drive? And that is what today's talk is all about, leveraging pipeline analytics as the foundation of DevSecOps. My name is Chris Riley. I am a senior technology advocate at Splunk, which basically means that I'm not a very good developer, but I could not give up on the enterprise application development lifecycle. I just love automation, love building applications, and so I participate in that by indirectly by interviewing companies and seeing how they adopt technologies. And obviously, one of the big things going on right now, because it's all over the news, is how do you build more secure applications? Well, to start, let's look at how most organizations treat visibility. They look at visibility in silos, and this might not be intentional, but it's certainly not intentional to blend the silos together. Where you see developers do a really good job at creating visibility in their sphere using something like maybe Prometheus. And then you see DevOps engineers and testing engineers do a really good job at visualizing their test results, visualizing maybe the metrics from the CI/CD process. And then in production, where we see the most strength in visibility and the greatest maturity in terms of monitoring, you have IT operations, you have SREs, and you have security professionals who are really good at monitoring what happens in production. Well, if you take both sides of these things, the security people have no clue what's happening in the application development lifecycle. And if they were to try to understand it and go down the hall and talk to the developers, developers would show them dashboards they've created, which would be meaningless to them. So you waste a lot of time just explaining to the security people what's happening in the application lifecycle. And what they want to know is that you're following policies, you're doing what you need to do to make sure you're scanning for vulnerabilities, you're securing your images, you're securing your artifacts, etc., your secrets management. And so it can be a tremendous waste of time. This is not the McLaren F1 scenario. You cannot sustain application velocity in a scenario where disparate teams do not speak the same language. And that's really what DevSecOps is all about. It's not about going down the hall and stopping everything for 2 weeks. Ideally, it's having the confidence and the information you need at your fingertips to understand what is going on. The other thing is DevSecOps is a practice. And because it's a practice, the entire practice needs to be visible. So what does it mean to be a practice? Well, it means it's not a tool that you go and buy and just start using. There's several use cases in it. There's several personas driving it. So to begin, let's talk about the use cases. The first use case is building more secure applications. So this is at the code, the building level of the application. This is putting the product together. What are you doing to make sure that that product is as secure as possible? Second, it's the software factory. So you have a factory that takes that product and puts it in production. But the factory needs to be secure as well. People getting access to the tools and potentially getting access to things that they shouldn't be getting access to. Or, as we've seen in recent news, injecting things into your delivery chain that are harmful to the product and expose vulnerabilities. And then finally, the thing that we already know pretty well, which is securing applications in production. We do this with SIEM, we do this with SOAR technologies, and we kind of have that locked down. However, we can make production security better by having a better understanding of what happens earlier in the delivery chain. And why do we implement this practice? Well, first of all, there are some assumptions here. And the first one is automation. There is largely assumption that your organization has invested in automation because automation is largely required here. The delivery chain, the testing, and also the visualization of all this data. And then finally, incident response, how you deal with incidents. If it is a manual effort, you're not keeping up with the velocity of application development and you're not able to shift left because you can't move security closer to the developer and make their job more difficult. You have to enable them and empower them to do the right thing with not a lot of additional effort. The other thing about this being a practice is it is not one size fits all. The organization top down needs to invest in an understanding that it is a practice and there's element of this practice that go beyond just your security tooling, but also thinking about visibility and what happens in the software delivery chain. Then once you get in the 3 different use cases, you see different personas driving the implementation. It's important to know that these are not the personas that necessarily leverage the data. The visibility is important for everybody, but they tend to be the ones who kind of own that data and are the greatest facilitators of visualizing it. So as we look at the 3 use cases, starting with building more secure applications, you see that developers and quality engineers especially are the ones who can point to the source of this data, but also your DevOps engineering team, who tends to have a very holistic point of view of what is happening in the software delivery chain. Next, you have securing the software factory. Securing the software factory generally is driven by the DevOps engineers. That's the way it is for many aspects inside of Splunk. But you will also see site reliability engineers getting involved because they are more and more getting involved in the understanding of the CI/CD process. And then finally, you have securing applications in production, which are your security professionals and your site reliability engineers. Now, again, I want to reiterate that everybody is leveraging this data, but different personas are going to be more honed in these various use cases, and that's really important. So let's look at the use cases now from a technology perspective, because this gets to the core purpose of this talk. So working backwards, first of all, we want to talk about what happens in production. Again, we're largely used to securing applications in production. We're used to using the SIEM as a security tooling, now getting more advanced into SOAR technology and maybe even auto remediation technology. We also look at observability. What does observability do for us for security? Well, it's a rich set of data down to the transaction level of your application. And if you're investing in real user monitoring, then you get even more data from your application. That data accelerates the understanding of when something goes wrong in an application, because oftentimes security incidents will also correlate to challenges in the production of the application in the application runtime itself. So performance issues, latency, strange behavior in a service, if you're a microservices application, can also be indicators of exploits. And then finally, you have incident response technology. Incident response is the mobilization, getting the right person at the right place at the right time, whether it's SRE or a developer on call or a security professional to address an incident that has happened. Once you have mobilized them, you have to give them the right context, the right data to help troubleshoot and address the incident. And finally, you have to give them the tools to bring in other resources if needed, or go to run books and Confluence articles to understand how to resolve an issue. One thing that is important in a true DevSecOps practice is that you have an incident response strategy and you're not leaning on ticketing systems as the method for addressing incidents. The difference is that a ticketing system is more static, system of record. You have to submit a ticket. Even if it's automated, somebody has to grab that ticket. Incident response is a push. All of these integrate together. So your SIM, your incident, or your observability are driven by an incident response platform that is responsible for the mobilization of the individuals and working to resolve an incident. Where do they get this data? Well, they get this data from the monitoring tool. But as we said before, that data starts at production. That data only starts once the application is deployed. There is a huge amount of data being missed in the SDLC. And by the way, when I say SDLC, I'm saying software delivery chain. So I know we are guilty of abbreviating things like SIM. So that data is powerful. It helps us understand deployments. It helps us understand deployment frequency. It helps us understand what artifacts were used, what test was used to test for vulnerabilities, etc. And so that's where pipeline analytics comes in, because pipeline analytics is a method for collecting data and visualizing it from your delivery chain directly, the telemetry from the tools, and building incident response on that data as well. So why are we looking so heavily at this idea of pipeline analytics? Well, first of all, if your delivery chain is not functioning as it should be, code doesn't ship, everything stops. Your software delivery chain, and this is the primary focus of this talk, is a part of your enterprise attack surface. And we've seen in the last 3 months, 3 massive delivery chain attacks that have exposed vulnerability in production level applications. One of them happened at the IDE, the integrated development environment, directly. Another one was injecting artifacts into the environment that shouldn't have been there, that were vulnerabilities in themselves, and nobody even knew they were there. And then the last one was getting access to secrets in the delivery chain, that those secrets could then be used in the production version of the application. These are all examples and different versions of examples of needing to secure the software factory. So if you're in denial that your software delivery chain is not a part of your attack surface, all you have to do is look at the news, recent news, and what everybody's talking about right now in the tech industry to know that that is not the case. It is. Part of all of this is efficiencies. We can't just increase our security considerations in the software delivery chain and increase the amount of effort of the team. So for everybody to speak the same language, we expect there to be a platform where the data collected across that platform may be different, but the lenses you create are consumable by the entire team, so that you don't have developers referencing one thing in one way and you don't have security professionals referencing something in a different way. The security professionals can look to see what's happening in the software delivery chain, have zero questions, don't need to interrupt the processes. Another thing that we forget about in terms of application security is this idea of configuration drift, or operational drift. And that is a form of technical debt that comes across your delivery chain, where potentially something, configuration on the development machine, somehow makes it into production. And that configuration is not secure. So part of an ongoing, continuous, healthy identification of technical debt is pipeline analytics. It allows you to see what's going on, to more quickly identify potential areas of operational drift. And then finally, this idea of shift left. Shift left is the idea that you move considerations that normally happen in production earlier in the software delivery chain. It does not mean it's the QA team's job or the developer's job. necessarily. You can move automation, you can move data, you can move all sorts of things without impacting the daily work of your engineering team. You can't shift left without visibility because you don't know what to shift. So it's hard to know if you're successful if you don't have a baseline and an ongoing visibility of what's going on. So if you truly want to shift left, visibility is necessary for everybody. Otherwise, you're going in blind. And that just is not sustainable. It has a short lifespan. So hopefully I've convinced you that pipeline analytics as a approach to creating visibility across the software delivery chain portion of your environment is a useful practice. The thing that's interesting about pipeline analytics is that it's not extremely difficult. And a lot of times organizations already have the tooling they need to do this today. But so many organizations are not considering it. And I have several theories of why. First theory is that a lot of times when we talk about DevOps, we reference DevOps in terms of velocity. It's more common to talk about going fast and automating and all of this stuff and not really thinking about how do we create visibility for that automation and how do we make that velocity sustainable so that when you get them in the McLaren F1, you have a helmet, you have a seatbelt, and you have a nice paved road in front of you. That's what this is all about. But the second is that they're not realizing that the software delivery chain itself is an application. It's the meta application, typically built by the DevOps engineers. They have features. They script as much as they possibly can. They have automation. They have all the components that you would see in a typical application, where the customer of this application is the delivery of software or your engineering team and your quality engineers. So if you get in this mindset that the software delivery chain is an application, then why wouldn't you treat it any different from any other application? Which means that you need to operate it, you need to make sure it's running, you need to secure it, and it needs to be measurable. These are all things that we do with production apps that we translate to the software delivery chain. If you can think about it in that way, it seems obvious that pipeline analytics is a practice that you already should be working on building. So operable, this is just making sure that it's up and running. This is the typical monitoring practices. Securable, this is making sure, this is the biggest aspect of DevSecOps, that you have secured the factory itself, you are protecting the code and how that code is delivered. And then measurable is, how do you know when you're doing a good job or not? How do you measure success? Now I'm going to dig into these first two, but the measurable one is interesting from a DevSecOps practice perspective, because a lot of times it's hard to get developers interested. And by implementing some of these key metrics, and a lot of people refer to them as the DORA metrics, but those are not by any means the only one, which is application velocity, change failure rate, mean time to recovery. These also help drive an interest in this type of visibility. So you can actually use these metrics, these KPIs, as a forcing function if you're having a hard time getting developers interested in DevSecOps and shift left. So how do you implement pipeline analytics? Well, first of all, again, the reason we're doing this is to monitor our software delivery chain, to create team level and global engineering team level KPIs, and to audit and secure your software delivery chain. I talked a lot about security, but audit and compliance in large enterprises is a big deal as well. The compliance team needs to make sure that you're doing the right thing to protect data. One way to do that is to create this visibility such that they don't need to stop the entire development process for several weeks to get this data. Now, how are you going to do this? And I know it's 3 bullets here, so it sounds super simple. And honestly, it's not that difficult, but there's some nuances to this. Well, the first nuance is this. Is your engineering team organized enough to be able to collect this data? That relates to the number of tools you have, how you name your projects, how you name your repos. You need to have consistency there. Otherwise, you're not going to know what you're looking at. You're not going to know how to segment information. That is a problem no tool can solve for you. No tool. This is an information architecture problem that the organization needs to think about. Once you have figured that out, then you're going to gather metrics and logs from the tools in your tool chain. There's a lot of ways to do this. We're usually familiar that most tools produce logs. For example, if you're using Jenkins, it produces logs. You can take those logs and store them into your logging platform. That is the foundation of getting the data in for pipeline analytics. But you have other ways. Maybe you're using a SaaS-based CI/CD tool or a SaaS-based repo. Your most common tools are going to be your CI/CD tools, your repository tools, and your incident response tool, with a close fourth being your backlog. Each of these tools are going to give you a different metric or a different data point in your DevSecOps practice. In DevSecOps, we have a few other tools that we look at, predominantly artifact testing, so tools like Artifactory, and SonarQube for tools like code quality, and also secrets management, tools like HashiVault. So these are specifically kind of DevSecOps related tooling. Now what's interesting is your CI/CD tool, like Jenkins logs, will get data from those, but you can also get data from them directly, like JFrog. You can get log data from JFrog. That's where you start to get into conversation about the resolution that you need and is appropriate for your environment, and a lot of it is going to be based on your tooling. But logs are not the only place. You can also use REST APIs and webhooks. Each has their pro and cons. So going from logs to webhooks, logs are the most verbose, give you the most amount of data, but that also increases the complexity on building visualizations. Whereas webhooks, real-time data, day forward, you don't have historical data though, you don't have the deepest resolution, but it is the fastest to start to build visualizations from. And then REST API, you can get historical data. You can almost get as much data as you would from logs, not quite, but it does simplify integration and it does make it more real time. It's not as heavyweight. You have to think about these things. And it's crazy that getting data in is one of the biggest challenges that we see in all of our customers, really. That is the first thing that you have to get right. Once you have the data, you correlate it and you visualize it. You observe it, and you observe it across teams. Most organizations are going to create lenses for different use cases. They're going to create a compliance lens, which is a compliance view, a view on access, so protecting the attack surface of the software delivery chain, and your KPIs potentially for your developers. Also operation, making sure things are up and running. So let's start with operation. Operation, keeping your delivery chain up and running, current, operable, is an important way to secure the software factory, but also to know if the software factory is not secure, if it's been exploited. You're going to monitor your delivery chain as you would most any application. And so depending on if this is a self-hosted application or a SaaS-based application is going to change this. If it's self-hosted, you're looking at infrastructure. So you're going to look at your typical infrastructure metrics: memory, CPU, disk, network I/O. Specifically network I/O in DevSecOps, because that can be an indicator if you see a peculiar spike in traffic or location from that traffic. Then you're going to look at the typical infrastructure metrics, which is usually called use, utilization, saturation, and errors. If you are looking at this more from a application perspective and you have access, for example, to the API gateway, etc., you're going to look at the red metrics, which is rate, error, and duration. And then finally, you typically are going to have a status, up or down. A lot of organizations will publish the status pages of the tool chain to the rest of the organization so they know if their tool is up or down. None of these are different than how you would monitor your own applications. Like I said, software delivery chain is an application of applications, and so you need to monitor it as such. Now let's get into auditing and really the core of DevSecOps, and not just um, there's a lot of elements. This is not all of it, but this is the bare minimum that any organization should be doing with their tool chain. These are checking the access to the tools themselves. So checking who is making requests to your secrets management tool, who is making requests to your repos, how frequent are the requests, where are they coming from, what policies are they attempting to use, what are the authentication types and methods. This is going to be true pretty much 100% of the time for all of your tools in your tool chain. It's the bare minimum. Now, when we start to look at DevSecOps, when we start to look at secrets management, for example, you're going to look at other things. You're going to look at the duration of leases. You're going to look at people making secrets requests for maybe root policy, because you shouldn't be having people getting root policy access to your instances. If you're looking at artifact management, or like Artifactory or X-rays, you're going to look at vulnerabilities. You're going to see the amount of vulnerabilities, and you're going to incorporate in your release process not allowing artifacts to go on if there is a vulnerability. This is also an opportunity to spot configuration drift, and another what's become, I won't call it a common, but a different type of attack, which is in your build process, are you pulling images down from a public repo? That's something that should never happen, but it's hard to catch. You would not have the opportunity to catch it without DevSecOps. In your repos, you want to know who's accessing your repos. How frequently are specific repos accessed? Do you have a rogue repo that nobody's been accessing but suddenly is? So you have anomalous behavior, because that is potentially a leak of intellectual property, or potentially somebody trying to inject malicious code into your repositories. Those are the primary: secrets management, artifactory, or artifact management, and your repositories that you're going to look at from a DevSecOps perspective. There's a lot here to consider. This is the foundation, but all of this is driven by pipeline analytics. Everything that I've talked about when we talk about monitoring, measuring KPIs, and stopping bad actors are all lenses on the pipeline analytics data that you are collecting. And here's an example of the lens. So this is a compliance center view of Spinnaker, I believe. And in this particular view, you're looking at the accounts that are being deployed from, who is getting access to the API gateway, so that's getting access to the release automation tool, the environments being deployed, so this is where you would start to look at potential configuration drift issues if a test environment somehow starts to make it in production, and also just the users who is actually doing the authentication. So in this case, you see there's an admin user, which is probably not a best practice to see an admin user frequently doing deployments. You probably want to see that coming from named users, but in this example, that is what we see. So all of this is to weave a thread from the software delivery chain all the way through your SIEM. Today, most organizations are good at creating monitoring. They'll use infrastructure monitoring for the infrastructure layer, APM monitoring for the application, and maybe even digital experience monitoring or real user monitoring for the front end. Organizations also tend to be really good with their security, leveraging SIEM and SOAR technologies to secure applications in production. But a lot of organizations have neglected to create visibility in the pipeline itself. And the way you do that is pipeline analytics. All of this comes together for what we call code to cloud visibility and shifting left security, so that you have visibility that supports the velocity in your F1 race car, and you can get from point A to point B and really understand what is going on during that time. Thank you so much. Enjoy the rest of the conference. Thank you for joining my session, and thank you for everybody at the Equilibrium Conference for inviting me. Have a great day.